Okay, let's get started with section 8.5, properties of logarithms. The first two goals here have to do with what we did in section 8.4. We'll be practicing it and going on to a couple that we skipped, and then we're going to do something completely different at the end and use some rules to expand logarithms or write them as a single log. Okay, so if we begin this first part, they're asking us to take the log of 9 base 3. And so we're being asked what exponent would be needed to solve this, okay? So 3 to what exponent would give us 9? And you can tell 3 to the second, so the answer needs to be 2, okay? Here we have the base as 5, and we're wanting to say what exponent do you raise that to? That's the unknown amount. The exponent is the answer to the logarithm to get 1 over 25. So I would think of this side over here for a minute as 1 over 5 squared, right? Because I want them to have the same base, right? I have a 5 over here, so we'll change this to a 5. And then we know that this can be rewritten as 5 to the negative 2. So we want it to be in the same form as this, 5 to some power. So we need a negative 2. And then you can actually check that, and you'll see that 5 to the negative 2 will give you 1/25, okay? All right, let's move on to the next one. We have a square root of 8 here. So this is a little bit weird. We want to write this in exponential form in a minute. So we're wanting to know what exponent would be needed to solve this. So 2 to some power will equal the square root of 8. First of all, I'm going to write that instead of radical form in exponential form. So I'm going to write that as 2 to some power is equal to, the square root is the same as the 1/2 power, right? Do you remember that? From chapter 6, I think it is. Okay, we need these to have the same base in order to compare them. So I'm going to make the base on both the smaller value, the 2, since it divides nicely into 8. And so I want to write this as 2 to some power all to the 1/2. So 8 is 2 cubed. So in other words, the mystery power here is going to be, when we multiply powers, when we have a power raised to a power, we multiply. Remember, we have the 3 over 1 times the 1 over 2 gives us the 3/2 power. So the power needs to be the 3/2 to give us the square root of 8. Okay, you could check that if you'd like with your calculator. And now this involves this rule that I skipped over in the previous section, so we need to look at it now. If you have a base and you raise that base to the logarithm of the same base of some number, then you just get the number that you're taking the logarithm of, the x, okay? This has to do with inverse functions. Do you remember when you take a number and you add something to it, and then you do the opposite and you subtract something from it, you end up getting right back where you started with, okay? And the same thing happens with other inverse functions, like let's take a number and square it. That's 25. And then let's square root the 25. And it gets us back to, because squaring and square rooting are inverse functions. Well, we would get a plus and minus depending how we were working on this. But we get back to where we started. So what happens, since exponentials and logs are inverse functions of each other, when we take an exponential function to a log power, we just get the number that we started with, the x. Okay, so in this particular problem, we have 3 to the log base 3. Those have the same basis of 17. So by this definition, it's simply 17. And I think that this is on your formula sheet. You may want to check. Okay. The same thing here. We have a base and a log base 6. So those inverse functions undo each other, right? And we are just left with this value, square root of 3. Very well. Next page. These are the properties of logs. These are new. This is the new topic in this section. And these are very similar to the properties of exponents because, like we said, they're inverse functions, right? Remember, when you multiply things that have the same base, you add their powers. When you take the logarithm of things that are multiplied together, you can rewrite that as an addition of the two logarithms. So the logarithm of a product is the sum of the logs. And remember when we did division, we subtracted the exponents with the same base? Okay, here we have a division in a logarithm, and we rewrite that as subtraction. When we had a power to a power, we multiplied. Here we're taking the logarithm of something to a power, and we take the n, the number out front, and we multiply it times the log. Okay, so these properties you need to understand. They should be provided on the formula sheet for the final exam. So you don't have to memorize those, but you probably will after you've worked some problems. Use these properties above to expand each expression. So we want to write it expanded out. Instead of a single logarithm, one log, we expand it out. So notice that the 3 is multiplied by the x, which is multiplied by the y. And when we have logarithms of things that are multiplied, we write them as sums. So this is going to be the log base b of 3 and the log base b of x squared plus the log base b of y. Now, since we have an exponent here with this x, we have to apply this other property that says when you have something to the power, you can put the exponent in front. We can multiply by the exponent. So we need to write this one more time to have it completely expanded. Log base b of 3 plus, bring the power in front, the log base 10. Oh, sorry, that's supposed to be a b. I don't know why I put a 10 of x and the log base b of y. So they're all base b. This is the answer in expanded form. That's a single log. We expanded it. Let's do the same thing with this. This negative exponent is a division. We could write it that way. The division is going to be written as subtraction, or we can use this power property, which I think is what I'm going to do. These 3 are multiplied together. So I begin by writing this as the log base 5 of x and the log base 5 of y squared and the log base 5 of z to the negative 1. Then I'm using my power property to take the powers and put them in front. Okay, so this is going to be the log base 5 of x and bring the 2 down. The log, multiply by that, base 5 of y, these are 5s, and then, oh, look what happens here. We actually have a negative. So the good thing about being at home is I have my whiteout handy. All right. So when I bring that negative 1 in front, put the negative 1 in front, then the log base 5 of z. So I use the power property to take the power 2 and negative 1 and pull those powers in front and multiply by them. Good. Let's go ahead to the next one. Here we have a product and a division with a product. Okay, we got a lot going on here. All right, so I'm going to start by taking this one times this one, and I'll rewrite that part as addition. So I'll begin with the log base 3 of x and the log base 3 of y. So I did the product there. Now this division, when you have division, you make a subtraction. So these are both being divided by. So I'm going to have to go minus. You could do this in a couple steps if you wanted, but I'm going to do it in one step. The log base 3 of 4. And it's multiplied by that, so I'm going to have to do this other part of the denominator like this, minus the log base 3 of z. Those are both in the denominator, so they both have to be, since it's division, they both have to be subtracted. So we've taken this and expanded it, and that's what they ask us to do. Let's take the next one. Notice this 4 applies to everything. So you have a choice. You could distribute this power through, right? You could raise everything to that power, or we could begin by putting the 4 out front. Sort of just a preference. I think I'll stick the 4 out front. So I'm going to think of this as the 4 times the log base b of x squared y. Now, as I write this, product, I'm going to have to remember that there's a 4 out front. So maybe the safest thing to do is put a 4 in a bracket, so I'll remember 4 applies to everything in here. So I'm going to have a log base b of x squared and a log base b of y. Since that was a multiplication, I rewrote it expanded as a sum, but I can't leave the x squared. I have to bring that 2 down in front of the log, so that will be my next step. This is 2 log base b of x by the power rule of logs, and then the 4 applies to everything. So my final step, 4 times 2 is 8 log base b of x, and then 4 times this one, 4 log, be really careful, it's easy to lose track of something with that. Looks good. Okay, one more. We need to write this in exponential form instead of leaving it as a radical. So the first thing I'm going to do is write this as the log base 5 of 2x cubed y. And we know that the square root, the index here is a 2, so we write that as to the power 1/2. All right, now since this 1/2, we could apply it to each term, or we could bring it down front. So I'm going to consistently bring it down front. 1/2 comes in front of a log, we don't really need that bracket there, base 5 of 2x cubed y. So all I did was I took the 1/2 and by the power rule, power property, I put the 1/2 in front. Now these are multiplied together products, so I now have to take and write that as the sum of the logarithms. So take the log base 5 of 2, and let's go ahead and put the 3 out front on that one, because the power rule, we're going to have the log base 5 of x cubed, and then we're going to stick the 3 in front by the power rule. And then by the product rule, we go ahead and add log base 5 of y. That looks good. Okay, so I did this product as the sums. Now I have to apply the 1/2 through. And notice that I also did the power rule here in the middle with the 3. Okay, so I have 1/2 the log base 5 of 2 and 3/2, because I multiply 1/2 times 3, which is 3/2, the log base 5 of x, and 1/2 the log base 5 of y. That would be my final answer in expanded form. Now you probably guessed what we're getting ready to do. We've been doing things expanded. Now we're going to go the other direction. We're going to take things that are expanded and we're going to write them as a single logarithm. Okay, that's where we are now. And I see the 1/2 in front of the very first term there, but only in front of that first term. So it only applies to the first term. I think I'm going to go ahead and put this 1/2 applied to the 25. So I'm just actually going to write that above just because I know it's going to take some extra steps. That's like the log of 25 to the 1/2 power. 25 to the 1/2 power is the same thing as the log of the square root of 25, because 1/2 power is in radical form the square root of 25. So this first one is simply a log base b, should write that every time, of 5. Okay, again, I worked that up this way. Play this back over again if you want to hear me explain that again. And then I'll go ahead and write this out. And I don't want to do too many steps at once. Now, things that are added, when we write it as a single log, we multiply them. So I have to take the 5 times the 3. Jam it together, multiply those. And minus means it gets divided by that part. Okay, so the final answer here is going to be, I'm running out of room, log base 3, 3 times 5 is 15 over x. Okay, log base b of 15 over x. This is a single logarithm that's equivalent to this expanded logarithm that we started with. Okay, here we go again. We have addition. This one's actually easier, the second one. So those get multiplied, and that's addition, so that gets multiplied. So we simply take the log base 5 of 4 times 6 times y. log base 5 of 6 times 4 is 24y. And that's all we need as a single logarithm. And finally, one more, and this one's going to be a little hairier. That power rule, we put that back up as a power as the first step. We write this as log base 5 of y to the third minus, we'll do that in a minute, the 1/2 I'm going to stick up here as the power. Log base 5 of x to the 1/2, which we know is a square root, but we don't really care because we'll leave it exponential probably. Now, subtraction, we're going to rewrite as division. So as a single log, this is going to be log base 5 of the y cubed minus, which we're going to write as divided by x to the 1/2. Or, I have no idea what my math lab's going to want on this, if they want it in exponential form or if they would want you to go ahead and write this as a square root of, sorry, it's not my math lab, is it? It's Hawks. The square root of x. Okay. That concludes this section. When you're ready, you can go to the next one.